Good day everyone, welcome back to my channel. Today we are looking at rates of change. Now when we talk about rates of change in mathematical language, we actually talk about gradients. And in everyday language we talk about slopes or how steep something is, a slope is. A gradient of a straight line graph is the rate of change of y variable relative to the x variable. Now let's look at some of the examples relating to this conception of gradients. For instance, the gradient can be described as m is equals to the change in y over the change in x. So technically what it means, gradient is the change in y over the change in x. That's standard. So when we deal with other concepts relating to gradient, of which I'll explain this later on when we reach our understanding relating to gradients. So we'll talk about the change in y over the change in x when we deal with pre-calculus concepts. We will be looking at, or rather more at, this domain of mathematics. For our understanding, grade 10, we will actually be looking at this analogy. So we specifically be looking at this symbol known as the delta symbol. So we have a delta symbol, we call this delta. So what does this mean? It means a change in Okay, now note, whenever we talk about the change of y over x, so we have this annotation yb minus ya over xb minus xa, which is the same as the change in ya minus yb over change in xa minus xb. Okay, it's the same thing. So it is also essential that you keep the order in which you subtract the coordinates of the points in the numerator and the denominator, of which I've actually indicated in this application here, more specifically this. Now we should be able to understand how this application works, especially when we actually work with the rates of change, especially when you are actually given, say for instance, a Cartesian plane, and you are to determine the rate of change or the gradient, the slope on a Cartesian plane of the two coordinates that are given. Now let's see how this application works in practice. So basically I'm gonna have to highlight a couple of pointers for this exercise. Okay, Now, let's look at a few examples relating to this concept. So we are to find the gradient of the following line segments. So we are given the following line segments. I'll call this number 1. So we have A. Okay. So we are given 2 coordinates. So we're given where x is equals to 3 and y is 7. And then we are given point B where x is equals to -3 and then y is equals to 3. Now, for us to find or rather determine the gradient equally is to actually annotate our original equation for gradients. Is m is equals to the change of y over the change of x. So by substitution, we actually need to substitute these coordinates into our equation or the general formula. So in this case, we're simply going to have our change in y. Essentially what we have here, we have 7 minus 3 over 3 minus -3. So by calculation, we have 7 minus 3. So 7 minus 3 gives us 4 over. So 3 minus 3 gives us 3 plus 3. Okay. So moving forward, we have 3 over 6. So essentially, what we can do is just to simply divide both sides. So in fact, 2 can enter into both numbers. I'm just using this for illustration purposes. So 2 can enter into 4 twice, and 2 can enter into 6 3 times. So essentially, our gradient is 2 over 3 or 2/3. Okay, let's look at another example. Let's look at example number 2. So this time we are given 2 coordinates. So this is now point C. Okay, now C we are given where x is equals to 0 and y is equals to 3, and then point D we have x is equals to 3 and then y is equals to 0. Likewise, when you are to determine the gradient, we're going to simply say m is equals to the change of y over the change of x. Gradient is equals to, by substitution, we have 3 minus 0 divided by 0 minus 3. M is equals to 3 minus 0 gives us 3. 0 minus 3 is -3. M is equals to, so positive divided by negative gives us negative. 3 divided by 3 gives us 1. So the gradient is -1 for these 2 coordinates. Let's look at a third example. So example 3, we are given two coordinates, so E and F. So the coordinates at E are where X is equals to 0 and Y is equals to 0. It means that they are at the origin. And then point F rather, the chord X is equals to 6 and then Y is equals to 3. Okay, so by calculations we have our gradients, so I'll just simply write it down here. So M is equals to the change of Y over the change of X. Gradient is equals to, so by substitution I just simply I can start with point F or coordinates of point E, either way. So you can actually one can always use their own discretion whenever they substitute, but one is to be very careful in maintaining the order in which you subtract the Y variables or other Y values with respect to the X variables or X values. So in this case we have our F and E, so I'll just simply substitute. So I'll start with F this time, subtract 0, so we have 3 subtract 0, and then we have 6 minus 0 as well. Okay, and then essentially what we have, 3 subtract 0 is just simply 3, 6 subtract 0 is just simply 6. So number that can enter into both numerator and denominator without leaving any remainder. We have 3 into 3 enters once, and 3 into 6 enters twice. Okay, so it enters twice. So our gradient this time is 1 over 2. Let's look at another example. I'm going to look at a couple of them today. In fact, I also like to amplify something here, or rather highlight one of the key areas that one is probably asking. If it's possible, or rather plausible, to start with another variable, or rather coordinate. Yes, like I said, one can always use their own discretion. So in this case, let's start instead of here. As you can see on this application, I started with using our coordinate for F. So I have F, I started with this and subtracted 0 from 3, and then I went to using 6, subtracting 0 from 6 below. So let's see how we can actually also be able to use the other, starting with E rather in this case. So similarly, I'll just say M is equals to Y over X, or rather change of Y over the change of X is equals to. So this time I'll actually start off with E. So, but remember, you always have to start with the with our Y coordinates. So we have 0 subtract 3 over 0 subtract 6. So M is equals to 0 subtract 3 gives us negative 3. 0 subtract 6 is negative 6. So notice they are both negative. Negative divided by negative gives us positive. So the number that can enter both numerator and denominator is 3, and 3 into 3 enters once, and 3 into 6 enters twice. Notice the answer affects the same results. Okay, so basically one can always use either one of them, but maintaining, or rather making sure that one is keeping order in which one subtracts the coordinates of the points. So if it's then starting with the numerator and then the denominator. Okay, let's look at another third example. Let's look at a third example. So a third example, example 3. For example 3, so we just look at example 3. In fact, let's look at example 4 because that was just our, that we just did our third example. So we look at example 4. Okay. Example 4. Okay, for example 4, that is D. So essentially here what we have here, so here we have G and H, point G and H. So essentially at G we have the coordinates where x is equals to 0. Sorry. X is equals to 0. And then y is also equals to 0. And h, x is equals to 4. And y is equals to negative 4. So by calculations, we devise our formula. So we have change in y over the change in x. M is equals to, by substitution, so we can start with h again. So we have negative 4 minus 0 over 4 minus 0. M is equals to negative 4 subtract 0 is just simply negative 4. 4 subtract 0 is just 4. M is equals to negative divided by positive gives us negative. 4 divided by 4 gives us 1. Again, our gradient is negative. Once again, for the fourth installment or this fourth example, let's look at a couple of other values or coordinates. Okay, so let's look at, okay, that was number 4, example number 4, number 5. Example number 5. B, C, D. So we had A, B, C, D, E, F, G, H, I, J. So we have I, J. So coordinates for I, so we have once again the point I at the origin, and then J, we have where x is equals to negative 3, and then y is also negative, but it's at negative 5. So by calculations, we're simply gonna write our formula, our general formula for our gradients. So we have m is equals to, so in this case I substitute again, so I start with I this time, so 0 subtract negative 5 over 0 subtract negative 3. Okay, m is equals to 0 subtract negative 5 is just simply 5 over 0 subtract negative 3 is just simply 3. So that's the last step for our calculation. So that's our gradient for Example number 5. Okay. So let's look at F. So we're going to look at number 6. Example 6. Example number 6. So example number 6. So we have J, KL. So this time we have, so this is our last example for the day. So here we are given two coordinates, K and L. So K is at 0, and that's X, and our Y intercept is at 0 as well. So the points at L are, where X is -6, and then Y is just simply 2. So by calculations, we're just going to denote our gradient formula. M is equals to the change of Y over the change of X. Okay, gradient is equals to, in this case we have 2 minus 0 over -6 minus 0. M is equals to 2 minus 0 gives us 2. -6 minus 0 is just simply -6. M is equals to, now notice, negative divided by positive, we have negative. So let's look for a value that can enter with the numerator and denominator without leaving any remainder. 2 into 2 enters once, and 2 into 6 enters 3 times. So that brings us to the last problem for the day. So thank you for watching. Please like, share, and subscribe to my channel so that I can create more meaningful or rather enriching videos. Please drop the comments below so that I can be able to highlight certain points relating to rates of change and gradients. So until we meet again, thank you for watching. Goodbye.